Okay, in the previous session, we were looking at the combinations, and we looked at one very important result related to combination, how to calculate NCR. And we applied some of the facts about the combinations, and we could solve some problems for unknowns. Okay, let's proceed further. So today we'll start with what is called as a restricted combinations. Restricted combinations. So we have basically three different restrictions that can be applied on the combinations. So we'll look at one by one. The number of selections, in the sense combinations, or I'll write combinations of, say, r different objects out of n different objects when that. So this is part A, or the first half. K particular items or objects are always included. When you want to include a specific number of objects in your selection, always. So K particular objects are always included. You include them always. So this means this can be calculated as n minus k c r minus k. At the same time, there is another clause for this. If you want to eliminate the k items, k particular items always. So this is k particular items or objects are never included. I don't want to include them at all. Then this is equal to simply n minus k cr. So I'm selecting r objects. So it depends on whether you want to select something or you don't want to select something. Right. Just dependent on that, I can make a decision. Okay. Then let's move forward. So this is the next point to remember. The number of combinations of R objects out of n different objects such that k particular things are not together, okay, in any selection, right? You have to make the selections in such a way that some of the items, k items, are not together at all, right? If that's what you want to calculate, then this is the equation: ncr minus n minus k c r minus k. Okay, that's the next point to remember. Then we'll move further to the third restricted combination. The third restriction is the number of combinations of n different objects taking r at a time when p objects are included always and q objects are always excluded. P are always included, Q are always excluded. If you want to calculate this, then this is equal to N minus P minus Q C R minus P. Okay, now, so let's move further. These are the 3 points to be remembered to solve the restricted combinations. Okay, this is a question to be solved now. In how many ways (11 players can be chosen out of 15 if, see, part A of the question, a particular player is always chosen. Part B of the question, a particular player is never chosen. So answer is very straightforward. Now you see, uh, It's related to the first point which we discussed under restricted combination. Out of selecting R objects out of N objects, if K things are always included, N minus K, C R minus K, right? So this is the function N minus K, C R minus K. This is what we want to calculate. What is N? N is 15. One of them is always chosen. So this, I have to choose totally 11. So this is 11 minus 1. So totally 14 C10 is the answer. Okay, 14 C10. Whenever we want to calculate a larger numbers like 14C10, what you can do is you can apply the following rule. NCR is actually equal to NC N minus R, right? So 14C10 is a bigger number. It's difficult to solve even using calculators. So what you do, you calculate 14C 14 minus 10. So that is actually 14C4. Easy to calculate. Simply you can calculate it by very useful method. Like what is 14C4? Right? So four numbers starting from 14. So 14 into 13 into 12 into 11 divided by the 4 factorial. Right? So that is 4 into 3 into 2 into 1. This is equal to 1001. That's the right answer. Okay, now we go to the part B of the question saying that a particular player is never being chosen. So for that, so this is answer for A. Now this is the answer for B. It says that N minus KCR, right? I know that N minus K, N is 15, and this is 15 minus 1, so 14. C, R is still same, R remains 11. So as you know now, you can easily calculate this using 14C, 14 minus 11, so that is 3. So this is equal to 364 weeks. That's right. So very straightforward. Just remember the particular restriction and apply the formula. All right. The next one. In how many ways 8 books are selected from 14 books if part A, 2 particular books. Okay, I'll write the part A here. Okay, if 2 particular books are part A of the question, always selected. Part B of the question, the same 2 books are never selected. Okay, this is the answer for part A, 924. Okay. 495. Yes. Let's move further. Next question. In how many ways 8 books are chosen out of 20 books such that the 4 particular books are not together in any of the selections. Okay, if you remember, this comes from the second type of restriction, right? We have to perform the NCR minus N minus KC R minus K. So in this case, the N is equal to total 20, right? I'm choosing R equal to 8 books, out of which K is equal to 4 books. So this is what I need to calculate. So ultimate calculation is NCR. So that is 20C8 minus N minus K. So that is 16C R minus K. So that is 4. This is what is the required answer. This comes to be 124150. Next question. In how many ways? Okay. 6 players out of 10 can be selected if 2 of them can never be in the same team. Therefore, the answer comes to be. Next question. In how many ways? Ten students can be selected out of 18 if 3 of them always get selected, but 2 of them never get selected. So if you look at this question, the question is basically falls under the third set of restrictions, right? Some of them get selected, some of them do not get selected. So the answer is equal to N minus P minus Q C. This is R minus P, where P is the selections, Q is not selected. Okay, so in this case, I can see that N is equal to 18, R equal to 10, P equal to 3, and Q is equal to 2. So n, that is 18 minus p minus q. 18 minus 5. Okay, so that is 13. 13c. This is r minus p. So 10 minus 3 is 7. So this is what you need to calculate. So this is equal to 1760. Next question. So mm, how many ways? 12 books selected out of, this is 20 books. If 2 books must be there in every selection and 1 book is never selected, so answer is 19,448 combinations. All right. Now we have another set of restriction, right? This is, you can take it as a note. All right. So I'll give a statement. The number of ways of n different objects getting selected at least one of them. This is given by, this is 2 to the power n minus 1. Okay. Now, there is actually another statement for this. This is called as the total number of combinations, right? This rule is called as the rule of total combinations, right? In a sense, I have n different objects. In how many ways you can select at least one, then two, then three, then four, and then all of them. It's something like what you are trying to calculate is, if you have n objects, it is nc1, nc2, nc3 plus all the terms, okay, up to ncn. This is the total combinations possible, right? This is given by 2 to the power n minus 1. That's what is the statement. Okay, let's solve one problem based on this. in how many ways? One can invite 8 friends by selecting at least one at a time. So one has to call his 8 friends, right? Has to 8 friends needs to be invited for maybe some occasion. Right. Now, at least one needs to be chosen at a time, which means you can choose only one or two, three, four, up to all the 8. So this means it is 8C1 plus 8C2 plus 8C3, etc. Right? I know that this is directly. We know that n is equal to 8. So we are expecting 2 to the 8 minus 1. 2 to the 8 is 256. Minus 1 is 255. So overall, you can do this in 255 number of ways.